All right, so we're going to talk a little bit about solving rational equations and then really talking about what it means to be an extraneous solution. So, the first thing I want to kind of bring up when we're looking at these problems is that this is no longer a rational expression. This is a rational expression, but now it becomes an equation because it has an equal sign. And, I kind of joke a little bit in class that equations have equal signs. And that's kind of the root word of what an equation is. And so the first thing we want to do when we're solving these is we're trying to find a value of x in this denominator that makes this whole side equal to 2. And what does that mean? It means that if I plug in a value for x, into this equation, and then I add 4, and that's on the denominator of a fraction, we're going to get a value that's equal to 2. And I'll show you what I mean near the end of this video. So in order to solve it, we need to really get rid of the thing that we're dividing by. And so in this case, we're dividing by x plus 4. So we need to multiply by x plus 4. Just kind of like what our multiplication would be in the previous part of this unit. But when we do to one side of an equation, we always have to do to the other side. So I have to also multiply the right side by x plus 4. Now, if we go back to our multiplication unit, we can find that, hey, like this is just, I'll do it in a different color. This x plus 4 over x plus 4, that's a fancy version of 1. So really, this left-hand side becomes just, they cancel out and they're just 1 is left over. And this right side is this problem 2x plus 4, 2 times x plus 4, but we have to distribute that 2 to both pieces. And so we get 2 times x, so 2x, and 2 times 4, which is 8, and this becomes a solving problem. So I'm just going to go ahead and quickly solve through. So here's our solution to this particular problem, and we go back to the original problem, and I'm just going to rewrite it so that we can do kind of our check here and make sure that we understand what's going on. So what this means is that if 1 divided by x plus 4 is equal to 2, then when x is substituted into the x value of this equation, it will equal 2. So let's see what that means. And this is a little bit beyond the scope of what this lesson is, but I think it's important that you understand what's happening here. So 1 divided by, we're replacing x with, here, I'll do this in color instead. So instead it's going to be 1 divided by x plus 4, where x is this negative 7 over 2. And we're going to say, hey, like, is that actually equal to 2? When I substitute that in, is it actually equal to 2? Now, I know how much you love doing fractions on a denominator, right? There's 2 fractions kind of going on over here. So I'll speed up the process by kind of doing it for us. But if we have negative 7 divided by 2 and then we're adding it to 4, that's the same thing as saying, hey, like this is 1 divided by 1/2. And that equals 2. Well, if we think back to our division section of this, this quarter, if I'm dividing fractions, I've got 1 divided by 1/2. I keep it, change it, flip it. This flips over to be 2 equals 2, and we can check that, yes, when I substitute x in, we get the true solution to this value, right? We found a value of x that makes the equation true. We'll do one more. We're not going to do the check every single time. Actually, we probably should do it every single time, and we'll talk about that as we get to the extraneous solutions part. So if you want to pause the video really quickly and just try this for yourself, I want you to try and find the solution here. It's the same kind of problem as before. Really, we're looking for a value, and maybe if you want to, you can do your quick check. All right, so hopefully you've paused the video maybe and gotten a chance to try it out. But we want to multiply by the thing that we're dividing by. So we're going to multiply both sides by x minus 3. We're going to multiply this side by x minus 3. And so the x minus 3's kind of go away and we're left with 1 equals, and then the 5 needs to distribute inside, and I'll do that in yellow because I think it needs to be slightly different than the title color. So 5 times x is 5x, and 5 times negative 3 is negative 15. Go ahead and solve. So we find that x equals 16 divided by 5. And it's going to be really important that you go through each of these, and you'll see why in just a moment, why we need to check almost everything we're doing, because sometimes we get an answer that's not actually true. So 1 divided by x minus 3, we're going to say, is that actually equal to 5? So I'll substitute in that yellow there. So we got 1 divided by 16 over 5, take away 3, equals 5. Now, if I wanted to kind of robustly do this, I'd have to multiply this other 3 by 5 over 5. So really what that ends up being is, 1 over 16 over 5 minus 15 over 5. And we see that's 1 over 16 minus 15, because their common denominators is 1 over 5. And you'll slowly see, right, if I bring that down, that we're dividing by a fraction, so keep it, change it, flip it. Yes, 5 does equal to 5. So that's just our check. I know that that's tedious a little bit. This is where things start to get particularly interesting when you're solving rational expressions. So now we're kind of mixing these ideas of multiplication, addition, simplifying, adding and subtracting fractions. They all come together in one problem, right? And so being really confident at those previous skills is going to support you as you move forward in these skills. So the first thing I want you to notice is that we've got a quadratic in the denominator here in this third term. And as we've talked before, we always want to see, is this factorable? And in fact, it is. And before this video, I spent a moment kind of doing the factoring process, right? That box method factoring, whatnot. But we found that we could rewrite this denominator here as x minus 5 times x minus 3. And I think that's really important to see kind of right there at the beginning. So I'm going to rewrite most of this problem. I'm just kind of copying 1 over x minus 5 plus x divided by x minus 3 is equal to 2 divided by the factors x minus 5 and x minus 3. Now if I were to multiply that out, I'd get the thing that was in red, and in fact I should have done that denominator in red, so sorry about that I didn't. All right, I want to tend to, hey, we've got non-like terms. Well, I'm going to do something a little bit funny, and I'm going to multiply by both of this common denominator that we inevitably need in x minus 5 times x minus 3. So x minus 5, x minus 3, and what I do to this side, I have to do to this side as well. So I have to multiply all of this by x minus 5 times x minus 3. Now you're going to say, hey, like, what's going on? Why did you make this so much more complicated? And I'll explain. Now, I'm not going to simplify this. I know that you want to simplify this, but I'm not going to do it just yet, because I want you to see that we're going to have to take all of this and distribute that to the 1 and distribute that to the x. So just take a look at what I'm doing. I'm going to try and make it as obvious as possible. So it's going to be 1 times x minus 5 times x minus 3. And then I'm going to do it again. So it's going to be all of that over x minus 5 plus x times, and I'm going to do it in yellow, so x minus 5 times x minus 3. All of that divided by x minus 3, and that's going to equal, so we're just kind of pulling down that equal sign, equal 2 times x minus 5 times x minus 3, all of that over the original stuff, x minus 5, x minus 3. Still, we're not going to divide anything just yet, because that's actually what we're going to do in this step. So I hope that you see there's a factor on the denominators that cancel out. So the x minus 5 cancels with the x minus 5. You can't just cancel the number part. You got to cancel the whole factor, because it's all being multiplied. And the x minus 3 cancels with the x minus 3. The x minus 5 and the x minus 5, the x minus 3, x minus 3. So we're going to clean this up at this point. What are we left with? We're left with 1 times x minus 3, which is just x minus 3. And plus, what are we left with? We're left with x times x minus 5. Okay, that's going to come in handy. And that's going to equal 2. Okay, we need a little bit more space. So I'm going to kind of push our space to where we need it. Well, this is now just a quadratic function that needs to be solved. And I hope that you see that you can distribute that and you can kind of bring it all onto the same side. So we got x minus 3 plus x squared minus 5x, and that equals 2. We're going to subtract 2 from both sides because we want it to equal 0. You'll see why in just a moment. I see that I've got like terms, so x and negative 5x, and negative 3 and negative 2. So that ends up being, what is it? I'll do that in different colors. So negative 5, and then we'll do it in green. So negative 3 and negative 2. So simplifying, we've got x squared, we've got negative 4x, and we've got negative 5. Now, I hope that you see, hey, this is a quadratic. We've got a lot of tools for solving the quadratic. Kind of thinking back to the last quarter, we could factor. We could use the quadratic formula. This is, in fact, incredibly simple to factor. So we're going to factor it out. So what two numbers multiply to negative 5 that add to negative 4x? And that ends up being, negative 5 and negative 5x and 1x. And so I'm just kind of doing my factoring here off on the side. We get x and 1. So x minus 5 and x plus 1. So now we can use the zero product property to finish solving. So we're saying, okay, I want to find a value of x. I want to find a value of x. Find a value of x that make it equal to 0. And so we know, using the zero product property, that if I do x minus 5 equals 0 or x plus 1 equals 0, we can solve for x. So plus 5, x equals 5. Subtract 1, x equals negative 1. Okay, so we're almost there, right? We're almost there. These appear to be our solutions. Now, I'm going to take a pause. I'm going to kind of go back and talk about what we did before I check these, because we need to check them. So we started with the stuff in the blue. We said, hey, I want to factor this out. I'm going to factor, and then I see, hey, I want to get rid of the denominators on this side. So I'm going to multiply by the common factor, distribute it. I notice that things can get cleaned up quite a bit. I can cancel out a lot of things. And as we, I can't move my slides. As we keep going, we find that we get to a quadratic formula or a quadratic function that we can factor and use the zero product property to get a solution. And I'm going to kind of do something funny. I'm going to zoom all the way out because I want you to see this check here. Is that if I go in here and I plug in my x equals 5 right there, it's going to be 1 over 5 minus 5 plus whatever x. Every time I see an x, I'm going to replace it with the 5. 5 minus 3 equals 2 over 5 minus 5 squared minus 8 times. Right, this is just going to kind of be garbage, right, for now. But I want you to see this here. This is really peculiar because what happens when my solution from down here is plugged in? What happens to it in the original problem? Well, the problem is that we're now dividing by 0. 1 divided by 0. That's bad. That's a problem, right? We can't divide by 0. And because of that, we need to say, hey, like, this actually isn't an answer. Like, we thought it was an answer, but when I plug it in, it's not. And so that's why we're checking every single time by plugging it in. Let's do it for the other one. Now, you'll start to gain an intuition. If I plug in negative 1 there, it's not going to make it 0. If I plug in negative 1 there, it's not going to make it 0. If I plug in negative 1 there, it's not going to make it 0. But what about this? What about this x squared minus 8x plus 15? It cannot be 0. The denominator cannot be 0, and so we need to check it. When x equals negative 1, will x squared minus 8x plus 15 equals 0? So let's check it out. So negative 1 squared minus 8 times negative 1 plus 15. 1 plus 8 plus 15, that's not going to be 0. I don't even need to finish it because I know they're all adding and it's not going to be 0. So the only solution to this is x equals negative 1 because x can't be the 5 that we thought it would be. I know this is a little bit complicated. Maybe you want to pause and review. Thanks so much for watching.